In the outer solar system, we have 4 gas giant planets, collectively called the Jovian planets: Jupiter, Saturn, Uranus, and Neptune. Although the giant planets are far from the Sun and very cold, the conditions deep in their atmospheres are quite different: hot, high temperature, and high pressure, and very strange forms of hydrogen and helium that are even liquid or crystalline. It's inferred that at the core of each of the gas giants is a rocky body several times the mass of the Earth, perhaps 3 to 5 times. The masses of all these rocky cores are quite uncertain because they're small fractions of the overall mass of the gas giants, and their presence is inferred by spacecraft passing nearby. The Voyager missions in the 1970s were the first to explore all the gas giant planets and infer their rocky cores, and give us some basic idea of their properties. Each of the gas giant planets has magnetic fields, a diffuse and large ring system, and multiple moons or satellites. A comparative view of the gas giants shows their sizes compared to the Earth. Jupiter and Saturn form a pair, Uranus-Neptune another pair, substantially smaller than the 2 largest planets. Saturn has the most prominent ring system. The other 3 ring systems were discovered in the 1970s and 1980s by spacecraft traveling nearby. It's thought that the ring systems involve failed moons, so they're just part of the formation process that leads to the extensive moon systems of the giant planets. There's a limit called the Roche limit, which is a distance from a giant planet whereby rocky material cannot form a coherent object because the tidal stresses caused by the giant planet would break it apart. So within such a distance, rocks cannot form moons, and you will be left with the debris of a ring system. The moons tend to be further out. Jupiter is really just a miniature version of the Sun, made mostly of hydrogen and helium. It has enormous weather systems. It's been known that weather systems must have durations of centuries because the Great Red Spot was seen when the first telescope was invented in the early 17th century, so it's been stable for at least 400 years. The belts and winds in the upper atmosphere of Jupiter are whipping around at 300 or 400 miles per hour. The subtle colorations that are often seen in NASA images are the result of false color. A true image of Jupiter through a small telescope reveals its coloration extremely subtle, very pale shades of yellow and brown. The coloration also indicates trace molecules beyond hydrogen and helium in the Jovian atmosphere, including carbon dioxide, ammonia, and methane. Saturn is notable for its ring system. The ring system is extraordinarily complex. Hundreds of discrete rings have been seen, and all are formed from the complex interplay between Saturn and its moons and the rocky material that forms the rings. If we could see the rings up close, we'd see a spectrum of particles made of mostly rock and ice that range from millimeters across to the size of houses. They're moving in loosely parallel orbits, occasionally colliding with each other and accreting, and sometimes violently enough to break apart. At times, spacecraft have traveled through thin parts of the ring systems with no bad effects. NASA's very successful Cassini mission has been exploring the Saturn system for nearly 10 years, gathering enormous amounts of data and taking exquisite images, in particular of the rings and moons. In an animation, we can see the complex gravitational dynamics as these moons shepherd rings and orbit the giant planet. Cassini has been extended for another 5 years, until at least 2017. As part of its visit to the Saturn system, it's made several hundred flybys, primarily of Titan, but also of many of the smaller moons. These are extraordinary feats of engineering, because in the best case, you can approach within 20 miles of an object that's nearly 1 billion miles from the Earth. Extraordinary confidence of the scientists planning these trajectories, since the loss of the spacecraft would be devastating. We get used to Hollywood videos and animations which don't represent the real science. The real science and imagery of Cassini is impressive enough. Here's what it saw as it first approached and traveled through the Saturn system. Uranus and Neptune are much less well understood. They've had visits by a handful of spacecraft over the last 30 years, but no close swing-bys and no landers on any of their moons. Some of the moons are interesting worlds too. While these are frigid worlds, they're not completely boring. Several of the moons have significant atmospheres and are heated by tidal heating, or natural radioactivity from within. It's also thought that several of the moons have liquid subsurface oceans. The four gas giants in the outer solar system were first visited almost 40 years ago, giving us indications that they may be interesting worlds and especially have fascinating moons deserving of further study. The best study we've made since then is from the Cassini mission, currently doing its work in the Saturn system. Cassini has produced exquisite data and gorgeous images on the rings of Saturn and many of its moons, in some cases flying by within 20 miles of the surfaces of several of the moons.